Hello again, and I'm here to tell you about motion graphs. So before I go on the motion graphs, let me just remind you of what distance, displacement, speed, and velocity are, because two of these are scalars, the other two are vectors, and knowing what they are is very, very important to get our motion graphs right, okay? So distance and speed, they are scalars. So that means that they have a number and that's all, okay? So it's a numerical description of either how far things apart are in terms of distance or how fast something is going in terms of speed. Displacement and velocity, they are vectors. So that means that they have a number and a direction, a magnitude and a direction, okay? So they may be positive or negative. So displacement ends up by being the distance in a certain direction, and the velocity tends to be the speed in a certain direction. So, and I know you saw this slide already. I have A to B, the displacement is A to B, but my distance traveled could have been going from A to C, and then D, and then B, okay? Same way, I have here two cars, both at the same speed, 25 meters per second, but they have different velocities. One is going in the opposite direction to the other, so one is going to have a positive velocity, the other is going to be a negative velocity. So we have this guy here at minus 25 meters per second, and this guy in here at plus 25 meters per second, okay? Now, this is very important because you're going to have different motion graphs according to if you're talking about speed, velocity, or distance or displacement, okay? So I have here two graphs that represent the same situation, okay? And the situation is, I have a ball that is thrown directly upwards. It reaches a maximum height of 2 meters and it will have a displacement of 0 meters and it travels a distance of 4 meters. So what does this mean? I go up 2 meters and I go back other 2 meters. So the distance that I traveled was 4 meters, 2 meters up plus 2 meters down. My displacement is how much my vector moved, right? My vector went 2 meters up, but then it went 2 meters down in the exact same direction, or in the exact same motion, or I forgot the word now. So vertically down, still vertically down, just as it went up, but in the opposite direction. So the total displacement is 0, okay? So my displacement time graph would look like this. My ball goes up to the maximum height and then goes back down to 0 displacement, okay? So that's my displacement times graph. Now this is different to my distance time graph. My distance times graph shows that the ball goes up, okay? Here you can see, because it's not because it's a curved line, you can see that it's slowing down. It gets to the maximum height, okay? And then it slowly starts to go down again, okay? So it's going down now. So I'm still increasing in distance that the ball is traveling, and it goes up to 4 meters, okay? However, it's just like me having a mirror right here. My displacement, well, here and up in here, okay? So my displacement time graph, distance time graph actually, shows the full distance that my ball traveled, okay? And the full distance were 4 meters, okay? Both graphs are going to tell me the velocity, or are going to tell me the information about the velocity of that ball, okay? So as you can see right here, when I reach my maximum height, my velocity is 0 because my gradient is 0. I have no inclination whatsoever for the graph, okay? Alright, so this is one example. Let's think about speed time graphs and velocity times graphs. So again, speed is a scalar, velocity is a vector, okay? So again, both graphs represent exactly the same situation. In this one, I have a speed that starts high, it goes to 0, and then from 0 it increases again to the same speed as before, okay? This could be the speed of the ball, for example, okay? So I throw the ball. In the beginning, the ball is moving at 15 meters per second, and then it has a steady decrease up to 0 meters per second. By this time, This is when I reach my maximum height, and then the ball is going to fall again. So it's going to go and increase its speed until it reaches the ground from 0 to 15 meters per second. Alright, that's my speed, my scalar, my number. Now my velocity, which is a vector, is going to have a positive velocity and then a negative velocity because I am going to change in direction. So my velocity time graph is going to be a straight line. Again, I start from 15, and within the same time I go from 15 to 0 meters per second. After, because I'm at 0 meters per second, I'm going to go back, okay? So I cannot go up anymore, so now all that I'm going to do is go back to the ground. So I'm going to have my velocity to increase from 0 meters per second to 15 meters per second. But now is in the opposite direction. So now I'm on the negative side of my velocity, okay? Because it's completely the opposite direction as in the beginning. Alright? Let me just check if I said everything in here. So the negative and positive velocities, so the motion in opposite directions, I told you this. In this case, positive is up and negative is down. Alright, the gradient of the line represents the object's acceleration, okay? Now, because this is a free fall, because I'm throwing the ball and no other forces besides of gravity are acting on my ball, my gradient is always equal to the gravitational field strength, which is 9.81. So I'm assuming that going down is negative. So my G, my gradient, is going to be minus 9.81 meters per second, okay? The area under the graph represents the displacement. So if you look at the area under the graph, it's going to be 0. Look at my velocity in time graph. That's my displacement, okay? I have this plus this, but this is equal to this, and one is positive, the other is negative. My displacement is 0. My distance traveled is this plus this, and I do have a certain distance traveled, okay? Now, I'm going to show you as well this amazing video from this guy that is showing you with animations better than I have, how you make the graphs, speed, velocity. I think he does actually the displacement, the velocity, and the acceleration. For a bouncing ball, okay, for another situation. Okay, so I'll put that video in, and I believe this is just another example. I actually cannot remember what I had in here. Well, this one is obviously the ball. This is, oh yeah, exactly. So this is the ball just going down. This is what would happen if my ball would go down and then bounce back up and then start going down again and bounce back up and going down again, okay? So this is what happens. This is just one bounce right here. A very sudden change in the direction of the ball, okay? But the velocity is 0 at that point because my ball is changing direction. Do look at this video. Yeah, that's something else. Do look at this video. It's amazing. I don't know who made it. It's not me, definitely. But the guy is very good, okay? So, oh, sorry, I didn't want to do that. So, I'm going to put the link in the description. And take care, have fun. And after this, I think I'm going to go on motion in a straight line. So, see you guys later and take care. Bye. Where is this to stop? Here it is. Bye-bye.